Ms. Riley, what's cloning?
So my name is Chris Tuggle, and I'm from the Department of Animal Science at Iowa State University, and my background is that I'm a molecular geneticist. And I'd like to answer your question, what is cloning? There are several different meanings for cloning, and I'll give you my interpretation of some of those different methods. The first method is what I would call recombinant DNA cloning, and that's very widely used in many molecular biology labs. Recombinant DNA cloning uses certain types of techniques in bacteria and in yeast to manipulate very specific DNA molecules for a variety of reasons. And I won't really spend any more time on that because I think you're probably much more interested in the other types of cloning, which are reproductive cloning and therapeutic cloning. In reproductive cloning, scientists are creating a new animal from the DNA or genetic material of a single parent. And that's different from the cloning, recombinant DNA cloning, where we're only working with a few molecules, a few individual molecules. In reproductive cloning, we're using the entire genetic material from a single parent. And of course, that's different from what we normally think of, where we have genetic material from each parent coming together to create a new individual. Reproductive cloning was used to create the very famous cloned sheep Dolly in Scotland by Ian Wilmot and collaborators. And their purpose there was to try to understand how you could actually create an animal from from a single parent, not having DNA from both parents. And this was a very interesting and exciting result because it had not been shown before that adult cells could actually be reprogrammed and the DNA actually be used to create a new individual from an old adult cell. So the process of reproductive cloning is you take the DNA or the whole genetic material out of the adult cell and you put all of the genetic material into a unfertilized egg in which the egg's own DNA had been removed. So you now have a new cell with the DNA only from a single parent. Then that cloned cell is activated and placed inside a surrogate female uterus, and then that cell is then allowed to gestate and develop into an embryo and develop into a fetus and hopefully come to term. But the process is really very rarely successful. In fact, the Scottish scientists took almost 300 attempts that failed before they were actually able to create Dolly. So this is a very rare event, a very rarely successful event. And that one step that I didn't explain before, where I said activation, is really critical. What happens is that we know now that the chromosomes from each parent actually are different, that the structures of those chromosomes are different. And so when you're doing cloning and the chromosomes are coming from just one parent, we have to reprogram and activate those chromosomes and try to mimic the idea of chromosomes coming from each parent. And we don't really know how to do that very well. Many people are interested in and very excited about trying to study that process, but at this point we don't understand how that works. So most of this reprogramming actually fails, and that's why we have so low a success rate in cloning. And this is really one of the major reasons why most scientists are opposed to doing reproductive cloning in human beings. And the reason for that is that because we know that we're going to have a very poor success rate, many human fetuses would suffer and perhaps even die before we would create that human clone. And so most scientists are against doing any reproductive human cloning. On the other hand, very many scientists that are interested in cloning are turning toward therapeutic cloning because it doesn't involve fetuses suffering and human beings being born from cloning. Although the early steps in therapeutic cloning is similar to reproductive cloning, in which you're taking genetic material from a particular cell that you're interested in and putting it into a embryo cell, an early embryo whose DNA has been removed. That's really where the similarity stops. In therapeutic cloning, instead of taking that cloned cell and then trying to gestate it in a surrogate womb, what you do is you're in culture. You take those cells in culture and try to change those cells into other types of cells, like liver cells or pancreas cells. And those cells then can be used to try to cure disease, either study disease or actually try to cure, for example, diabetes, but with pancreatic cells. So you could also take those cells and perhaps even develop them into a useful organ or set of tissues that could be used in organ transplants. And so that's one place where scientists are very interested in using cloning, but instead of reproductive cloning, actually use therapeutic cloning. And in fact, there are some scientists that have been very successful with some new technology, stem cell technology, in which they've been able to take stem cells or identify stem cells and be able to start to work with them in the laboratory and create new types of cells from them. And in fact, there are some recent successes with adult cells, which in terms of finding stem cells, which would perhaps allow us to completely avoid using unfertilized embryo cells. And we would avoid the whole issue of using those early embryo cells entirely.